In the government's latest response,
you must stay at home.
Master of the house, doling out the charm.
It's very important that everyone
know that you are not alone.
G'day chemists. So let's have a review of our topic test. Well, not a review of it, let's go over how we do each question. So in this, we are looking at doing the, sure you can hear my next door neighbour just revving the guts out of his car, out of his four-wheel drive. We're going to go through nomenclature of all of the different organic compounds that are part of our syllabus. So, one of the very first things I need you to be able to identify is functional groups. Now, functional groups are a tricky idea because what it means is what a functional group is, it is the identifying feature, or basically the chemically most important feature of that organic compound. So here we have a bunch, and let's have a look. Now, most of these are done with skeletal formula. Remember, with skeletal formula, each point is each point on a line is a carbon, and it's assumed that it's saturated. In other words, all of the spare electrons are bonded with hydrogens unless otherwise stated. So if we look at the simplest one, which is the alkane, that's it up here, we see that we have a 1, a 2, a 3, a 4, a 5 carbon alkane. There's no double bonds because double bonds are represented like this, okay? And triple bonds are represented like this. And you'll notice that the triple bond actually changes the shape of it a little bit, but that's just a different thing, don't stress. So that's our single triple. So that's our hydrocarbon groups, okay? So we have alkane, and that being 5 is pentane. This is also 5. 1, 2, 3, 4, 5, 6. Actually, that's 6, sorry. So this becomes hexene, because it's got an alkene group there. And this one has a triple bond, so that's an alkyne. And it would be 1, 2, 3, 4, 5. So that'd be pentyne. And it would be numbered in the way that gives the functional group the lowest possible. Now remember, the functional group is the most reactive part. So, in this case, it would be pent to ine. And this one over here would be pentane. No numbering there. And this one here would be, that's a hex. So it'd be a 2 though. Hex 2 ene. Now, that's the straightforward one. But we can see how we have found the functional group. We found the most relevant part. Now, a bunch of this we won't look at. Okay, it's just got very little to do with us. But there are some which does. So here we have the functional group for a ketone. Now what this looks like is we have a C, another C, another C, then a double bond O. So if you see something like that, and the rest of it is just straight chains, we can see that it is a ketone. If it was on the outside, but this is what we're looking for. That's our functional group. So our very first step in naming something is we look for the various functional groups and we see what is the highest priority. There is a list that's in all your notes. You can find it all over the internet, so we won't do it now. But one thing I will say is that a carbonyl group is very high. Carboxylic acids, which is, I know this one caused some problems. A carboxylic acid is a COOH, and that's the highest priority, and there's a whole bunch in there as well. Okay, so let's carry on. All right, question 1. Identify the following compound. So the first thing we want to do is we're going to look for any functional groups. So we don't see anything on here that makes it anything other than a carbohydrate. So we know it's an alkane, alkene, or alkyne. And if we have a look, we don't see any double or triple bonds. Everything is single bonded. And one way to test it, if you're not sure, is that you look at each carbon and it has 4 bonds coming off it. Like this carbon here has hydrogen here and a hydrogen there. That's the H2 and 2 off. So it can only be 4 atoms coming off it. If it had 3 atoms coming off it, one of them would be double bonded. So it's all single bonded, and then we count the longest chain possible. 1, 2, 3, 4, 5, 6, 7, 8. And that gives us octane. This is a fun one. So let's have a look at what we have. First thing, so this is all skeletal formula, which means each one of these has a bunch of hydrogens coming off. And each point is a carbon. So that's just for our guide. And each of those is filled up with hydrogens. But let's have a look at this one here. So this carbon here has 3 bonds off on this side and 1 over here. So this has no hydrogens, nor does this one. That'll be important in a minute. So let's have a look at our functional group. Our functional group here is, well, this is an alkyl group. So that's something we name methyl, ethyl, propyl, whatever. So that actually goes in the front. So that's really low priority. But we have this one here. So we have a hydrocarbon with a triple bond, and that makes it an ine. Okay, so that's this. Now we want to number it. We number it so that we can find the longest chain. So see how this diverges around here? So one of those is part of the longest chain. They're both the same length, so it doesn't matter. You get to choose. But the other one is a separate group. But we number it so the functional group has the highest priority, which means we number from this end. So it's 1, 2. So it's oct2ine. That's our only option with oct2ine. But let's check our ethyl group at the end. And so we have 1, 2, 3, 4, 5, 6. So that would be 6. And that's 2 carbons long there. So it's 6 ethyl octine. So now we have a look at naming this compound. They're all naming, well, nearly all naming compounds. All right. So the trick here is, do we number or do we count along this chain or along this chain? And the cyclo is the one that actually takes precedence here. Cyclos are really hard. Well, not hard. They're just sort of the top end of our course when it comes to naming. Some people find them really easy. I don't mind them too much. Other people do. But my point is they are just part of that system. But they're sort of, you won't see many of them in our course. Anyway, so cyclo. So we look at the cyclo first and go 1, 2, 3, 4, 5. That wasn't the numbering in order. That was just me counting them up. So that's a pentane. Okay. So we know it has to be that out of the 2. But then we have these ones here. So let's see how they come about. So these are our ethyl groups. And we number them in whatever way gives us the lowest possible. So we could go 1, 2, and that would make this one a 4. Add those up. So 1 plus 4 is 5. So that's no good. Whereas if we go this way, 1, 2, 3, we add those up. It's 4, or 1, 2, 3. Either way, it's 4. And that gives us our lowest possible numbering. So that gives us 1, 3. Oh, actually, diethyl cyclopentane. But 1, 3 ethyl cyclopentane is the closest correct answer. All right. This one was really tricky and it confused a lot of people. So we've got 2 potential answers down here. It's a cyclo because it's another ring molecule. There's 4 in there. 1, 2, 3, 4, which makes it a butte. But remember, the first thing we want to do is we want to look for the functional group. And that's this. That's this double bond. That is the most important chemical component. So that makes it an ene. And then we have cyclo, because it's 4. Because it's ring structure. Bute, because it's 4-ene. Now, you can number this one or not. It's actually not that important because no matter how you number it, the double bond here, because it's a cyclical structure, will always be the number 1 position. But either way, it's cyclobutene or cyclobute 1-ene. And then we have this one. This one was fun. So, look for the longest possible chain. Now, it's not this way. Okay, because it's 1, 2, 3, 4, 5, 6, 7. It's this way, which gives us 8. So we get rid of that one. Now, the numbering becomes tricky, right? So we want to number it so that when we add all these up for our ethyls and methyls, we have the lowest possible number, which means we need to start on... Actually, we'll number the methyls first. So we go to give them the lowest possible priority. And it doesn't matter. There's actually an error on the answer here. And we corrected this when we marked it. What it should be, that's what was confusing me there. It should be 2, 4, 6 trimethyl octane, because there's 5 again. No other functional groups. But this should be a 3 ethyl. So it should be 3 ethyl trimethyl octane. 3 trimethyl octane. All right, so we look for a functional group. We've got something different now. So it's an ane, but there's also this bad boy, which makes it so that's a hydroxyl group, and that makes it an alcohol. Okay, so then we number it. Now we can number it from the left to right. Actually, then we look at the infix, which is, does it have any double, single, or triple bonds? Only single bonds. All right, nice and straightforward. So that makes it an an. So we've got ol, and then we add them up. 1, 2, 3, 4. So that makes it a bute. But we will need to number it because the alcohol could be here or it could be here, and it would change the number. So we want the lowest possible. So it becomes butanol. All right. Now we want to identify the nature of the functional group present. And here we're giving you the options of primary, secondary, or tertiary. So there's 2 of these questions in the paper. One is for alkanols, one is for, I think, amines. We'll get to that as we get to it. But with alcohols, there's our group there. That's our functional group. We look at the carbon it's attached to. So we look at it as this unit. And how many is that carbon attached to? If it's just attached to 1, so if this one here doesn't exist, and that's an H, that would be a primary. But what we actually end up having is a secondary. We have a secondary because we have this one and this one as well, so it's attached to 2. All right, name the following compound. We have a methyl group. It's an alkane, or it's the longest chain, which could be either that way or that way, would be an an. We have an alkyl, or methyl, I'll give it its proper name. But our functional group, which is the first thing we find, is this one here, hydroxyl, which makes it an ol. So we want to put all these together now. So first thing, functional group, that's identified there. These are the other things which could affect the naming. And that's the highest priority, so we give it to this one. So that's the suffix. Okay. Its longest chain possible is prop. But we will need to number everything because, especially the alcohol, because that could be on the end. I guess technically we don't need to number the methyl group because it can only be in the middle there. I would, just because it'll make everyone's life easier if they were to try and build this molecule. But this one then becomes 2-methyl, because we go 1, 2, 3. We number from the other side if you want. 2-methyl propanol. So let's have a look at this one. So we've got only straight single bonds, okay, no doubles or triples. We have some hydroxyl groups, and we have some alkyl groups. And as our previous example, the methyl alkyl groups don't outrank the hydroxyls, so it becomes an ol. So let's count them up. We have 1, 2, 3. All right, nice. Now let's have a look at our methyl groups. We've got 1, 2. So that becomes a triol and becomes a dimethyl. Our highest priority are the alcohols. So if we're numbering it from this side, because that'll give us the lowest, 1, 2, otherwise it would be 3. 3, 4, 5, 6, 7, 8, 9, and that makes it a non. Okay, single group, so it's an N. All right, let's put this bad boy together. So we have non and nonin, 2, 4, 7 commas triol, and it's going to be a 3 and a 6 dimethyl. And that's our answer here. Name the following compound. Okay, so we look for this, right? We've got a cyclo. It's only single bonds. But we've also got another hydroxyl, which makes it an ol. But it is a cyclo, so we have to write cyclo at the front. There are 1, 2, 3 carbons, so it's prop. Which means we get to, and it's only single bond, so it's an an. So we get to call this one cyclopropanol. However, you can number it cyclopropan 1-ol, but because it's only got one alcohol group or one hydroxyl, it's only ever going to be a cyclopropan 1-ol. So it couldn't just be called cyclopropanol. So which here is the highest priority in naming? This is just sort of remembering from our list. Carbonyl has the highest. Hydroxyl is below that. But alkyl doesn't even make it on the list. That's actually always listed as a prefix. R here typically represents a hydrocarbon chain. Not a carbohydrate because there's no oxygens in that. Not a carbonyl group. These are just the ones that I find are common misconceptions. And not actually a carbon chain. Like you could call it that, and some people do call it that, but it is best to think of it as a carbohydrate. Oh, sorry, I do that all the time. A hydrocarbon chain, because it has the hydrogens on there as well. Formaldehyde is also known as methanol. That was just remembering it from things we've seen in our lessons. This one here is which of these four represent isomers. The easiest way to do this is to, in our working out, is to just break each one down into its chemical formula. Like compound W is C4H. I'm not even talking about structural, compressed structural, just chemical formula or molecular formula. Oh, get out of that. Is H1, 2, 3, 4, 5, 6, 7. H7. There's a Cl there. Let's do that one. Cl2 and F1. Exalpet. All right. Compound X, which is, by the way, our correct answer, so we'll do that one. And then we'll just do the next one. Is C4H1, 2, 3, 4, 5, 6, 7, 8. 7, sorry. I counted that F. And Cl, there's 2 of them. And fluoros, there's 1 of those. And that's the same. So let's have a look at this one. This is the other tricky one. So go 1, 2, 3, 4. So C4. Okay. This one doesn't have enough carbon, so that's out anyway. Go away, Y. You're not wanted. H's, 1, 2, 3, 4, 5, 6, 7. So 7 H's. Could be the same. Cl, there's only 1 of those though. And fluoros, there's 2 of those. So you see how, well, you don't need to write the ones, but you'd write the ones just because it's helping you count it all up. And that gives you the correct answer there. Identify the following compound below. This is the pentanal. You know it's an anal. We'll keep it PG here. You know it's an anal because it's on the terminal carbon. So the functional group here is a carbonyl group. And the addendum to that, so it's a carbonyl group, but it's a carbonyl group on the terminal carbon, so the end one. And that makes it an aldehyde and an anal. Whereas it would be a ketone or the suffix -none if this carbonyl group, again, that's that one. I love carbonyl groups. I don't know why I enjoy them as much as I do, but I really do. The carbonyl group was on, say, the second carbon or whatever. That would make it a ketone. All right, next one. So, name the following thing. This one was one that you actually all got wrong, but because of me, not because of you. Well, some of you, because of me. And that's because I included this and this, which is named it twice. And in this case, that one was not meant to be there. It was just an example from across. It's just an artifact of me putting this thing together. Okay, so let's add it up. First off, we find our functional group. And that's, so we've got a carbonyl group, and we've got 2 methyls. Everything else is single bonded. You can see that by checking, like this only has room for 1 H, which is right there. Same over here. And these are 3s. Yep. So we have a carbonyl group which is not on the terminal, and that makes it an one. Then we've got the methyls, so it's a dimethyl. It's an an because there's no double bonds or triple bonds. Then we add them up. 1, 2, 3, 4, 5. We can number from either side. So it's a pentane. And then we put all this together. That's on the 3. So the way we would like you to number it is 2,4-dimethyl. And no break in there. Should we just dimethyl pentane? 3 in the middle here, one. However, chemists will also number it 2,4-dimethyl 3-pentanone. And I was accepting that because, again, I'm not teaching you to do a test. I'm teaching you to be a chemist. Okay, so name the following compound. Oh, by the way, according to the Meet the Markers, both those will be accepted for those of you who are more worried about doing the test. Okay, so here we have an anal, okay? And we know that because we have a carbonyl group. If you get confused, where this one caused confusion was it a hydroxyl group? Now, there's a way to see that. So, as this is written CHO, that means the H comes off on its own, and the O is there as well. Now, if it was written as COH, that would indicate that there was a C bonded to that O directly, and then the H is after that. That's a really tricky part of this in a compressed structural formula. That's what this is, compressed structural formula, where everything is grouped around its most recent C carbon. So, because this is a carbonyl group and it is on the end, we have an al. There's only single bonds, you can see, because if you add them all up, every carbon's got 4 atoms coming off it. Which makes it an, so it's an anal. And then we can add those up. Now the numbering part becomes a problem. We want to number it to get, so we've also got a chloro group. Now chloros have super low priority. In fact, they're lower than alkanes. So that's numbered last, whereas our anal is numbered first, and it's a 1. Now, there's 2 potential answers here. One is 7, because it's the 7th along. And there are 8, so it's an octanal, 7-chlorooctanal, or 7-chlorooctan-1-al. But remember, any anal has it right on the end. This is fun. Cyclohexanone, cyclohexanal. So the trick here is with a cyclo, which one do you do? There is no terminal carbon for the carbonyl group. So that means that it has to be an anone. There is no cycloanals. Okay. Identify the following compound. This is a propanoic acid. This represents CO for the functional group, OH. And that's a carboxylic acid. So there are 2 different misconceptions here. There's one that it's an alcohol. Makes sense. I can see how you get there. And the other one is that it's an ethanoic acid because there's 1, 2, and then the functional group. But if the functional group has a C as the center, a carbon as the center, we include that in our counting. So 3. So that makes it propanoic acid, except obviously, as Ms Elliott says, we flip it and reverse it, and we number it from the functional group. And functional groups, you don't need propanoic acids. Any carboxylic acid, you don't need to number the propan 1-oic acid because it's always number 1, unless it's a dicarboxylic acid. Okay. We're almost there, kids. Doing well. So here we have butanamide or butane 1-amide. So our functional group here is an amide, and that's that one there. So we have an NH2 off there and a carbonyl group. Those combined give us an amide. An amine would be just this, okay? But so an amide is amide. So an amide is an amine plus a carbonyl. All right, and remember we include that C as part of it. And because of this bonding here, that means amides are always again terminal carbons. We'll get to some weird numbering of amines and amides in a minute with the next question or a question coming down the pike. So it would be from here 1, 2, 3, 4. So it's butane, no double bonds, butanamide. So but this is the functional group. Remember, that's what we're always looking for first. Then we have skeletal formulas. You know they make me happy, but they do confuse some people. So let's have a look at what we've got here. We have this section there is our functional group. Okay, it's a carboxylic acid. So essentially it represents this, which again makes everyone happy. There we go, C, carbon, carbon. If you're unsure, feel free to just redraw them, remembering that each point is a carbon. So yeah, check this business. That's way gross compared to the elegant and beautiful skeletal structure. But whatever, you get to choose. Anyway, so we have a carboxylic acid up here. That's number 1. Woo! Then we go, we number from there. 1, 2, 3, 4, 5, which makes it a pentanoic acid. It has a methyl group here coming off the number 4 carbon. So that makes it a 4-methyl pentanoic acid. We also accepted 4-methyl pentanoic acid as one word, just because you've been told to make it one word, but this one's a bit tricky. And then 4-methyl space pentanoic acid. Now, just, I know that they're not technically right, but if you wrote any of these, or aside from that one, that's gold. But if you wrote any of these, I would still give marks because you've not shown that you don't know anything. You've shown you know exactly what it is. It's just numbering's a bit weird. Okay, we're almost to the back end now. Yeah, so close. Okay, name the following compound. We've just got this, which makes it an amine. Okay, there's 1, 2. Remember, we want to number it so this has the lowest possible. So our functional group is amine. There's only single bonds, so it's an an. And there's 4 of them, so it's a butane 2-amine. So butanamine, or 2-butanamine, or butane 2-amine. Then we have this one, which is just tasty meatball. Okay, so there's 2 questions about the one compound. That's why we've joined them up here. So first up here, we have another amine. So it's an NH though. So it's just an N. That's the N that makes it the amine, right? Just like in an amino acid. So we have the N here. And we have to pick the longest consecutive chain, which is not this one. There are a lot of people who put this down as a propanamine, but it's this one here. So that makes it, so that's too long. So our functional group is amine. Our functional group, our longest chain is hang on, I'll get rid of that. Ethan. Okay. This one here, the amine has to be on number 1 because it's the but we don't need to number it with ethan. If it was prop, we'd need to, but we don't need to with ethan. But we will, just for the fun of it. But then there's this one. This one's a real jerk. because it's coming off the N, and that's making our lives hard. That's a methyl group, we know that. But how do we number it? Well, we number it to show that it's not coming off a numbered carbon, it's coming off the nitrogen. So we give it an N. So what we end up with is N-methylenamine, because we don't need to number the amine on this one because it's only 2. Or if you really want to get, we'll also accept N-methyl and N-methylane 1-amine. And then the next question off this was identify the nature. Is it a primary, secondary, or tertiary? So, just to be a jerk, in prior ones we've talked about that, like with hydroxyls, that it involves the carbon that it's attached to. But with amines, that's actually not true. It just involves, I'm sorry, I don't make the rules. It involves how many carbons we've got coming off the nitrogen. And as there are 2 carbons coming off this nitrogen, that makes it a secondary amine. Now we're naming carboxylic acids. We've highlighted the functional group here. We wanted that to stand out for the first one. Well, not the first one, but we wanted it to stand out for this one. What we were really looking for is how did you name it and how did you number it? Did you include this carbon and did you number it from this end or the other end? Which obviously you would number it from this end. So it's a carboxylic, well, obviously, that's rude. I shouldn't say that. In this case, yes, you would number it from this end. So it's carboxylic acid, okay? And we've got 1 because we include that carbon, 2, 3, 4, 5, 6. Or, no, let's do it. 6 just for fun, because we can do that, which makes it a hexanoic acid, and it has 2 methyl groups, boom, 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 off the 4 and 5, so it's 4,5-dimethyl hexanoic acid. Now, these numbers could be lower if we numbered it from this side, but that'll give us a really high number for our hexanoic, or for our alkanoic acid. All right, last question. You've hung in there well. Identify the correct name for the following compound. Whew! All right, so we number alphabetically here. So there are no functional groups on here beyond the fact that it is an alkane. Okay? Remember, our halogens don't count as a functional group. They are only ever put at the front. So we have chloro times 1. So chloro. And we have fluoro times 2. Now, fluoro is after chloro in the alphabet, so chloro gets the precedence in naming if there's nothing else there. In this case, there's nothing else there. So the chloro is a 1. Simple. And that makes this one here is a 1, 2. So what we end up with is 1 chloro, 1, 2 difluoroethane. And you'll note that all of our options here were down to the numbering. That's really what we were testing there. All right. I hope that made sense. Any questions, put them in the comments below and we'll get back to you as soon as we can. Well done on the test. I'm still happy. Everyone showed growth and everyone, I think, has stuff that they can take away from this and work on. But yeah, that's how we do that topic test. Peace out. See you next time. Thanks for watching. Bye now.